Wonderful. We've still got a steady flow of people coming in. So just while we do still have people coming in, I will kick us off because I think we are about on time for that. So hi, everyone. Welcome to this afternoon's event. My name is Abby. I'm part of the RecWorks team. I work with Barry Cranford, who's the founder of the LJC, among many other communities. Obviously, they are all run by RecWorks, the bits we do, and we absolutely love running these events. As a company, we're a tech recruitment company, but we have a massive difference because as a company, we believe that recruitment can actually be a real force for good in the industry beyond just placing people in jobs. We believe in doing events like these where people can learn and others can share knowledge. We love linking people together in that aspect because for us, that's a way of giving back to people we've had a relationship with in the past, but also paying it forward to those we hope to work with in the future. And for us, that's a really big part of what we do as a company. We're not just hard hitting, oh, we've got to get you in a job and that's all we do. We love to build these communities and relationships and enable people to share knowledge where they've got it, and likewise accumulate knowledge where they want to. We've so far run over 700 events across all of our communities. With developers with the LJC, with students, graduates, CTOs. We've run conferences, hackathons, lightning talks, all sorts of different things. We've also made over 3,000 different connections so far through our Meet a Mentor program. And we're always looking, like I say, for opportunities to link people together, whether it's through the Meet a Mentor program or through communities like this one. So this afternoon, we have got two great speakers. We've got Alex, first of all. He is heading Redis Technical Field Engagements in EMEA, excuse me. He and his team are in charge of technical awareness and solution architecture for customers, prospects and partners in that region to put Redis adoption on the right track when developing modern applications using Redis in-memory and multi-model database, and also when bringing it to production on any platform and clouds at any scale. Previously, Alex was leading the pivotal technical field around Spring, Cloud Foundry and Kubernetes. In the earlier days of Java, he worked on the BEA JRocket JVM, aspect-oriented programming, and was a committer in Eclipse Aspect J. Today's topic, as you can see, is Redis caching, multi-model DB, and event processing with Java Aspect. So with no further ado, I will hand over to Alex and I will introduce Kamran a little bit later on.
Yes, thank you. Thank you, Abby, and very happy to be with everyone today on this virtual event. I think it makes sense for, Kamran also to introduce yourself. We're in there together for lots of demo and content about Redis. And Kamran, over to you.
Hi, guys. Kamran Yousaf. I work, I'm a solution architect with Redis based in UK. And my background is low latency, high throughput systems. And in this talk today, we will walk you through how you can use Redis with Java, and we will go through some simple use cases, and also we will go through some beyond cache, more complex use cases, and we will show, we will talk through the theory, but also show all those things in action also. Alex, over to you.
Yeah, awesome, Kamran. Yeah, as an additional motivation for your presence today, we have a draw as well, so you can win this gorgeous, starfighter from Star Wars. Obviously a Lego box, some red colors so that you can think about Redis when you have it. To enter the draw, you can scan the QR code at the bottom left, and don't rush to do it right now because the QR code will be displayed on many slides. So you have time to scan that code, no worries about it. So yeah, you may have heard about Redis, or you may not have heard about Redis, right? So let me just cover some of the basic of what is Redis, right? Redis is an in-memory open source database. It's designed for high performance scenarios, really mixing for going after operational need, like high read, high write kind of throughput applications, but also doing analytics on the data set. And more, Redis is also used not just as a key value kind of no SQL kind of platform, but more as a multi-model database. And we will cover that today. What are the primary use cases and how Redis is brought into action, not just from a key value storage and in-memory system, but for covering use cases such as streamings, graph database, and full text search onto that platform, whether you deploy it on premise or on cloud. Redis is not new in the community. It's a very large community. It's open source. It's been created over 10 years ago in 2009, and is really considered as the leading in-memory database platform. Tons of innovation going into this community, whether it is from the server side or whether it is from the client side. The server itself is actually written in C. It's extremely lightweight, extremely scalable, and it can be also a distributed system in a shared nothing architecture. So you can go really for kind of infinite scale. You can find more if you're interested about the community and the source on these links. If you want to learn more about Redis, we have the community website. And if you want to understand better how to bring Redis to production with Redis Enterprise, whether it is on-premise, on Kubernetes, or as fully managed on cloud, you can check out our redis.com website as well. Some bit of history, I've been into the Java landscape for almost 20 years, and Redis was created more than 10 years ago. You can see, the history of Redis, being in love with Java, or maybe I should say Java being in love with Redis, is pretty much also more than 10 years. The first client library for Redis, so that your client application in Java could talk over a remote protocol to the Redis server, was really created early on, obviously, with the name JDIS, like Java Redis 1.0, first release made in 2010, shortly after the Redis, first release as well. That client library is still very famous in the community. In any Java application, version 3.7 was released, a few weeks ago this year. Lots of compatibility with Redis newest version and all data structures and protocol. Another Java client that is pretty famous is Lettuce. Same thing, about 10 years of history for Lettuce. The big difference though is that Lettuce is designed after reactive programming, or at least more recently was shifting to that design. So if you're doing more asynchronous processing or have adopted reactive architecture, it might be a good candidate as well. Of course, you might be using Spring, or you might be using Vertex as higher level framework, and Redis has been integrated quite deeply into these as well. Same thing, 5-10 years ago, Spring Data Redis for simplifying the way you can build application using Redis as a store. If you're using Spring Data, for example, and want to expose some RESTful API with your microservices, or simply with Spring Session and driving session scalability for your web-based application with Redis as a storage engine. We will cover that in the demo and how to get started with these kind of client libraries. Of course, if you haven't heard about Redis, you may wonder, how famous that is, how adopted that is. And just speaking about communities, whether you look at, Sumo Logic, which, really is looking after what's running in Amazon, they run like a monitoring platform. So they have some insights about this. Redis scores number one in terms of technology, kind of database technology, NoSQL technology that is running on any Amazon workload. If you look at Stack Overflow, they're running like a developer community survey every year. And every year Redis is ranking number one as the most loved database. And we will see in a minute how easy it is to use Redis on one hand, getting started, getting stuff done with your favorite language, but also how easy it is to kind of go at scale in production and deliver the performance your user expect with that kind of technology and the data you're putting into Redis. As you may observe, and as we are going to try to demonstrate to you today, Redis covers a number of different use cases. You can start really easily with caching use cases. Having some backend being slow. You want to protect the backend from peak load, and you're going to introduce Redis as a cache. This is a really famous, architecture. Lots of capabilities for that. As you do more with Redis and rely more on it, it really becomes a database, right? It brings persistence. It brings horizontal scalability. You're going to use this for high-speed transaction, read and write, maybe even to a point where you kind of flip the database up and down and it becomes like a messaging platform, right? So we will cover that as well in some of the demos and deeper dive. And over about 2 years ago, maybe, we've introduced RediSearch and Redis Graph, for example, where you can really manipulate complex data set directly into Redis and still operate Redis the same way and use the same kind of client libraries. Kamran, over to you. I think you want to make a few points about the top 3 reasons why people consider Redis, right?
Yeah, thank you. Thanks, Alex. So if you just stop sharing the screen, and I will share my screen. Okay, so Alex, Redis is extremely popular, and it is also one of the most deployed databases in the cloud. We think there are 3 reasons for that. First of all, is performance. It is the fastest and most scalable database. Redis is synonymous with performance, speed, and low latency. There are a few reasons for that. First of all, it's written in C. The data is served entirely from memory, is single-threaded, and it is log-free. And if you go to the open source code and go to the discussion, you will find that there are discussions about hardware affinity, how it can utilize the hardware most efficiently. So you can do more with less hardware, and it's as fast as possible. Then Redis is a key value store, but it is a data structure, and the values are data structures, and those data structures, they are written extremely efficiently. It has gone through multiple iterations. Most of the commands in Redis, they provide, regardless of the data size, constant response time. Then on the client side, it provides a network protocol, which is efficiently and very, very easily parsable. It also provides pipelining. What that means is that you can combine multiple commands together and send them in a bunch to Redis to reduce the network round trip time. So you get the lowest latency. Many of our users, they are deploying Redis with terabytes of data, and they are getting sub-millisecond latency as when they are connecting to Redis. We did a benchmark on AWS, and we showed there that we can achieve 200 million operations per second with less than 1 millisecond latency. 100 million operations were reads, 100 million operations were write. We started with 1 node, and for 200 million operations, we went to 40 AWS instances. And there is also a link for that. We have provided the link for that. And Redis database is scaled linearly. Second, Redis, it is a key value store, but as it's the values, they are quite complex types also. So let's start with the simplest types, strings. Strings, they are binary safe strings. This is the most popular type. If you are using Redis as a cache, probably that's the first one that you will start using. And you can store images, text snippets, any kind of data using the string type. You can also use string types as counters, and it provides you the atomic counters. You can do concurrent operations, and none of the increments or decrements, they will be lost. All those operations, they are atomic there. You have hashes. These are Redis inside Redis, multiple fields and values. If you are doing object mapping, or there are lots of frameworks that do object mapping for Java or for .NET, and they use hash to store the data inside Redis. Lists, they are just simply linked lists. And you can use lists to build queues, job queues, or efficiently build stacks also. Redis also provides you with location data types, geospatial indexes, where you can do location-based operations on those. Everything is orthogonal. Picking it up is extremely simple. All you need to do when you are working with Redis, you go to the redis.io website, and there are, for each data type, there are commands. You can go to that, you can go to the data structure type and look at all the different commands that it supports. So if we just go to lpop, you will notice here that, okay, it provides lpop, the command, provide the key, and then how many elements do you want to pop. One important thing here is that for every command, the big O is provided. So it tells you up front that as data grows, how will the command scale there. So you are never surprised when you go into production or into your performance testing that what's happening. Another important thing is that there is a key space notification mechanism that you can use. If when the data changes, you can get notifications on the change of data. And you can set up time to live for each data type, each data that you put there. That's the underlying all the data structures there. Third one is modules. I've shown you 10 core data types that come with Redis. Modules extend Redis and add new data structure and capabilities rather than the core team to catch up and add more data structures. There are many modules available. Redis as a company, we provide certified modules, and there are a lot of open source modules, or you can write your own modules also. There is a search module that's a replacement for Elasticsearch, and if you want to do instant searches there. There is a JSON module to put JSON documents in and turn Redis into a document database. There is a graph module that you can use for connected data and do Cypher queries. There is a TimeSeries module, and there is a Bloom module for probabilistic data structures that I will go through. We will cover some of these modules later on in our presentation. Okay, now Redis, it has a very large community. Any language that you can think of, there is a library or multiple libraries available for that. For the most popular languages like C#, Java, Python, Go, there are different libraries with different philosophies. And for more niche languages, for example, for R or Julia, there are libraries also available for those. So it has a very extremely rich library system for programming and building your applications. Alex, over to you. So I'll just stop sharing.
Yeah, thank you, Kamran. So let's deep dive a little bit onto, some of these data structures in action and look into, a typical web-based application architecture, whether you're using like a monolith because you're still kind of modernizing some somewhat complex system, or whether you're designing microservices-based architecture, most of the time it would look something like that. You have a core application running there, maybe scalable or divided into a set of microservices. You have a strong dependency on maybe a legacy database somewhere or a system that is somewhat fragile, and you might want to accelerate this with some caching. And of course, you have a number of users and variation in your workload that you need to deal with. And over time, you will add additional scenarios like asynchronous processing into this architecture. So, obviously Redis can add a lot of value for, caching scenarios where you can protect the backend and have, write through, write behind, etc., cache aside, whatever the name you want to use. Essentially read the database, keep the data in the cache, maybe expire the data with TTL, time to leave, into the cache and deal with it this way. Over time, you may want to plug Redis into your session store. It can be extremely useful if you're using microservices and have authentication framework, and you need shared identity across the microservices as well. And as you maybe expose more API in your application, you might use Redis to store counters and use those counters for rate limiting onto these APIs and improve governance and security into your application. So let's take some examples and then use the demo application to really see that in action. Let's start with the lowest level approach here, which is really the Redis command line, right? You could run Redis on your laptop. You could use the command line Redis CLI and just practice a little bit yourself. So if you're using key value and value being this data type string, whether it is an opaque binary safe string or a very simple one, you would start with like a set command to kind of write into Redis. It goes through the network under millisecond and write the data into Redis, whether it is standalone Redis, Redis in highly available setup with master and replica, or even a clustered Redis distributing the keys across nodes. And then you can read that key later on from maybe a different process in your application. Of course, you can set TTL, like 60 seconds expiration, and the server would take care of that. And then you can remove the entire data set if you need to as well. If you're using Java and JDIS, all these commands, they really map one-one to what JDIS does provide in terms of Java API. And you can use your IDE auto-completion to kind of, use this and check the website redis.io /commands to just validate what you're doing and better understand this. If we take a more, complex examples, let's use hashes where the value is a hash map. Typical use case could be a user session. You want to maintain the state of the user session into Redis. You may have like an object and a number of values right in that session that is changing over time as your application is getting more complex, and you need an extreme performance on that part of your architecture. So hashes are perfect for that. You can write the entire hash as one data structure. Then you can update or retrieve some elements. You can even increment a counter within the hash if you need. So if we use this as a simple example here, just conceptually again, this is my user session. I'm storing the name of the user, the IP that he is coming from, and maybe the number of time he went onto a very specific page that I'm interested in, and I want to keep track of that. So maybe, as the user gets in, I would write the entire hash map. So you can see there's a key and then a number of key values for the hash map that would obviously map Java objects in your code or something. You could read the entire hash map, or maybe just a subset of it to just ensure you have the maximum efficiencies. You could, increment the counter, and then it really only going to increment just that part of the map. So it's very efficient on a network as well. And as it goes, you can possibly, organize for this to scale. And you can see in this little yellow box that I have here, this concept of key space. There's a convention in Redis to use like the key space name, comma, and then a number or a unique ID to kind of really identify the key and then get different data structures organized together into the same Redis. So that's an example here. And then let's have a look at adding a field into this map, right? So later on, if you change your mind, you need more information about the last page that this user has visited. You don't need to refactor, the entire data structure. You just add a field, and it just get added. Can read that, and then possibly can even remove the field, and then it sort of gets cleaned up by the server, and then possibly remove the entire session later on, right? So very basic use of Redis, And to see that, let's just switch to a Java application and see, a little bit of Redis in action here. So to give you some context, I'm going to use like a web-based application. It's all built around Spring Boot in Java. It's going to use JDIS as the client libraries to connect to Redis. And the first part of the application is going to rely on a MySQL database. So the application is a movie database, right? It gives me like a catalog of movies with some information about the movies, like the title, the release date, and things like that. And I want to improve that application. I want to possibly add a rating score, right? I want to look up the score of the movie, in the movie communities, the historical score, reviews, etc., that people have done that movie. And that score is provided by an external API. So this is an external service. We're going to use the Open Movie Database service here, omdbapi.com. And given a movie ID, you can look up the ratings of the movie. So they provide an API. If you give it like a movie ID, here is the movie for Guardian of the Galaxy, that would give you a number of information, but this, I have it already in my database, but they would give you this rating section here. And I want to provide like a microservice that would just, expose that rating into my application. Of course, I don't want to hit that external API every time because it might mean a dependency on an external system. It might be done. Or it might be expensive because maybe there is some rate limiting and I need to pay after some requests, etc. So we're going to try to solve that sort of architecture. So as we said, you could possibly run Redis, as a very kind of simple one command, right, in your laptop using Docker. You can use Redis and all the modules with just that change using the Redis provided image for Redis with the modules, if you need search and graph into it, for example. In this architecture, I'm actually using Docker Compose so that my microservices and my Redis are kind of, all starting together in somewhat a consistent architecture. So I can show you that quickly. I have a Docker Compose file here. And using that Redis image with the modules, exposing the port, maybe even my laptop, but more importantly, exposing the Redis kind of server onto the internal Docker network so that my other microservices can essentially use that, right? So that's kind of step one. In this project, I have many microservices, but we're going to focus on one, which is the caching service. And the caching service is a Spring Boot application. I'm using Maven to build it. I've configured the Spring Boot dependencies, JSON for serialization later on when I need it, and JDIS for my client library. I'm not going to use too much of the Spring kind of higher level abstraction. I'm going to use JDIS directly in there. So I'm going to have a pool to connect to Redis using JDIS. So configuring the host and the port. So, using your typical framework, that configuration is usually externalized, in an environment variable or properties file, etc. JDIS provides you with all the capabilities for, security, failover, cluster compatibility, and anything you need from that kind of connection pool. In that application, that microservices here is actually used in the UI. So let me show you this microservice in action before we show the code. So if I look up a movie like Interstellar here, I have this little bit here that tells me the rating that I get from the OMDB API. And that part of the application is actually the part that is provided by my microservice. Essentially, my microservice is going to look up this information into the external API and possibly cache it using Redis if I turn on the cache. And it would keep track of the number of time I did an external call to the external API or not, and maybe I kind of found this into the cache. So if I look into my microservice and give it a movie ID, that's the rating that I would got from the external API. And I would track also the number of time I've hit the cache if I've turned on the cache into this code. So let's have a look at the code just quickly. This is my REST API. So typical Spring Boot application using REST API and providing a movie ID. Then I'm using this web service caching service. And if we zoom into the code here, this one is going to make an HTTP call to the external OMDB API, is going to use JSON. And, there's a strategy, am I using the cache? If I do use the cache based on the configuration or the UI, then I look up the hash into Redis. You can see this jdis.hgetAll, so that I look up the entire hash from this from the Redis database. Of course, if I don't have anything into the Redis database, then I need to look up the information using an HTTP request to the remote server, doing that call, incrementing the counter in Redis that I did an external call to the OMDB API, and then reading the result of that, OMDB API complex JSON, parsing this just to remove what I don't need, and creating the structure I want to keep in Redis. And then I just write this into Redis as a hash. All right. So by key, providing the key prefix, like the namespace of that key, and the ID of the movie. And then maybe I would use TTL to keep this in the cache. So let's just use that capability into our application now. So if I'm using that movie and turn on the cache and just refresh, making that call again. Now I'm hitting the OMDB API one more time. Now I have the info in the cache, and next time I hit that, I only hit Redis. I don't go outside, and the application is much faster. You can see I'm not calling the API outside. I have a millisecond response time in here. To have some familiarity with what Redis is doing in the back, you might want to use Redis Insight. This is a tool we provide. It can run as an application standalone, or it can run as a web-based application as part of your Docker architecture. You can then connect to your Redis database, have an overview of what is in there and what's the traffic going on. And you can then explore the structures into Redis. Here we've loaded some structure by this naming convention cache. And as we just hit the cache, I now have this structure, which most likely is this hash, where I have this info about the rating that I've been looking up outside. And you can see this hash was given a TTL. So in about 50 seconds, it will just disappear from the cache, and so on, right? So Redis in action, caching scenario, extremely scalable, extremely easy to introduce in your application. That use case was a cache aside kind of scenario and architecture, but Redis can do way more than caching. Let's switch to Kamran, because I think Kamran, you want to make a few points about using Redis for PubSub and streaming architecture.
Correct. Thank you, Alex. Yes. So I'm just sharing my screen. And so Alex showed a very simple use case for Redis being used as a cache on top of MySQL database. Redis can also be used as a messaging system, and it provides multiple mechanisms for building distributed queues, sending notifications, event sourcing, and distributing data with the different guarantees. Where does it fit into your architecture? So a request comes to your application servers, and you want to do some asynchronous processing. You want to put the message on a job queue. There are job servers that pick that message up and do the processing. Redis streams or Redis lists or the PubSub mechanism that can be used for job queues. And there are many open source libraries and frameworks and applications available that use Redis for the job queues there. Then you are processing your requests, either the user's actions or the logs or any other kind of data you want to pass it to the warehouse. That's where you can use Redis streams. Again, that's a data type in Redis, and we will cover that in more detail there. And if you have your web services and they are communicating with each other, you are doing event sourcing, or you are sending messages between different microservices. It's a very popular use case to use Redis as the bus for communication between microservices. Let's go into a bit more detail now, and I will show you what are the different guarantees there also. So Redis PubSub provides an efficient mechanism to send messages to multiple consumers. For example, if there are IoT devices, they are sending sensor data and you want to send them to multiple services. Or you want to send a message, you are using WebSockets and you want to send messages in the web application to your end users in the web browser. You can use PubSub for that. It's a lightweight mechanism for distributing messages. There is no setup required. You just create a channel, someone publishes a message, and the subscribers, they will receive the message. The important thing to remember about PubSub is that it is fire and forget, or at most once delivery. So you publish a message, the subscriber is offline or no one is listening, the message will be lost there. How can we use that? So if someone Redis provides a subscribe command, and here we are simulating that we have a service that applications, they can subscribe for the weather information about different cities. And when the weather information is published, they receive that information. So here we are subscribing for Stockholm. And you can also subscribe for multiple messages also. So here, another application on the left-hand side in the red box is it has subscribed for 2 channels, Stockholm and Madrid. Now, when a message is published to the Stockholm channel, the message, it goes to it, both applications, they will be receiving, or both subscribers, they will be receiving that message. And if we just publish to Madrid, there is only 1 subscriber there, the red box, and it will receive that message. The same mechanism is used inside Redis if you want to get notifications on data changes. If you are setting a value, you are updating a value, or you're deleting a value, Redis also provides key space notifications whenever data changes, and there are PubSub channels available to subscribe to and be informed about the data changes. Now, the important thing was that with PubSub, it was fire and forget, or at most once delivery. What if the data is more important? You cannot afford to lose that. That's where Redis streams come along. It's a very versatile data structure. Stream is an append-only list of entries called messages. Messages are added to the stream by producers. There are commands available for that, xadd command. And then every message, it has an ID. And if you don't provide an ID, an increasing ID, then a timestamp that's automatically added to it. The data, that is immutable, but you can delete the messages, and you can also cap the size of the stream. And in one simple Redis server, you can have millions of Redis streams there to process. And it provides you with many mechanisms to do the process. So I will go through a few of those scenarios there. Okay. So the most simple scenario is that you have created a stream, a producer, it is putting messages on the stream, and then there is a consumer, for example, a messaging service, and it is consuming those messages. And the messaging service, it will receive all the messages that are published on that stream. Second scenario, you can have multiple consumers. So in this scenario, the producer puts the messages on the stream, and then each of these services, they get every message that is published on the stream. Now, in many cases, when you are publishing your, when you are consuming the messages, a single service, the velocity of the data, that's quite high, and the processing can be expensive. So you want to fan out those messages. That's where the consumer groups come along. Streams, they support consumer groups, and in a consumer group, you can have more than one consumer, or you can have multiple consumers, as many as you want. And the messages, they are fanned out to all these different consumers in a consumer group. So one message that will go to image processor 1, the second message that will go to image processor 2, they will do the processing. The consumer groups, they also have the Redis streams, it keeps tracks of what message it has sent to which consumer in the consumer group. And the consumer, it has to acknowledge that message back. Otherwise, the message stays on a pending entry list, and you can query that, okay, what are the pending messages that have not been acknowledged in case a consumer got a message, but it did not, it failed and it did not send an acknowledgement back, so you can process it again. This way, Redis streams, they provide at least once delivery guarantee to your applications. And again, I wanted to emphasize that they are lightweight data structures, and you can have hundreds of thousands or millions of them in a Redis process. You just create a stream, start publishing. It follows the same way, a key, and that points to a stream. And now you can combine all the previous different scenarios that I mentioned. You can have multiple producers, you can have multiple consumer groups, and you can have multiple consumers also. Another important difference is that you don't have to decide upfront that how many consumers you will have in a consumer group. As new consumers come along, the data will automatically be distributed among them. Okay, so Redis streams, you can use them to build quite complex workflows. In the demo, I will be showing you that, okay, the movie data comes in from MySQL, we transform it, we send it to the search service, we send it to the graph service. This exactly the same pattern, it is being used by the company that runs UK's rail networks. As a train passes over a sensor on the track, the signal is processed and the information is displayed live to the operators sitting in the train stations. And they are using Redis streams and RediSearch for that functionality. Okay, now I will move to the multimodal database. Now, Redis is a key value store. What that means is that you add a key. If you have to get the data back, you provide the key and you get the you need to know the about the key. What modules do is that you can add your own different turn Redis into a multimodal database, and you can write your own modules depending on your business functionality. We at Redis, we provide certified modules. The source code is available online, which if you want to try, you can try those. And I will go through a few of those modules that are available. So first of all, RediSearch. RediSearch is built for a real-time search at scale. It provides querying, secondary indexing, and full text search for instant experience. To use RediSearch, you create an index, and and then use the RediSearch query language to get to your data. It is quite feature rich. You can do quite complex queries to search your data. You can build catalogs, you can do secondary indexes, you can do suggestions, you can do aggregations there with the RediSearch. So let's see how we can use RediSearch. So the first of all, again, Redis is still a key value store, and index it sits into the same key space. So we run the command ft create and say that, okay, create an index. And what I want to index all the hashes that have a prefix of ms:/docs:/movies. So as you write your data in real time, it will do the indexing for you. And then that hash, it has different fields. It has a title, which is a text, and then it has a plot, which is, and you can specify that, okay, it's sortable. You can also specify numeric data types, and you can also specify text. Once you have built the index, if you build an index, it will automatically index the data. And as new data comes along or a data is updated, it will keep the index up to date. And now when you want to do a search, that's the query language. Okay, which index do I want to use? And then you provide the different conditions that I want all the movies that were between 1990 and released between 1990 and 2010, and the genre that was animation. And I want the result to be sorted by release year. And for paging, I want to start from the 40th element in the result, and I want the next 10 entries. And different libraries are available, extensions for JDS and Lattice, they are available for all these for RediSearch module there. Now I will move to the next module, RedisJSON. So there were many patterns to store. If you are just interested in storing a JSON document and just getting the full document back, probably string, it is the most efficient data structure for that. But in many cases, when you are storing RedisJSON inside storing JSON, then you want to just get one attribute, or you want to just update one value or one attribute in the JSON document. In that case, it is an overkill to read the whole document, update it, and write it back. That's where the RedisJSON module comes along. It supports storing JSON documents as a binary tree. You can get individual values or multiple values, supports JSON path, and it also integrates with RediSearch if you want to search on your index your JSON documents, and also search on them. So that turns Redis into a document database. Again, a very efficient document database. If you have connected data, you can use the Redis graph module. Redis graph module allows you to store connected data. The difference is that it uses sparse matrices to store the relationships, and then does very efficient linear algebra to traverse the graph there. The graph module supports a subset or Cypher querying language that you can use to insert the data, update the graph, and also get the data back from it. And again, extremely efficient and works at a memory speed. How do you query the graph? Again, there is a command available. Provide the key for the graph that you have created, and then provide the Cypher string. Here I'm saying for a movie, give me all, I want to search for a movie that has a title Annie, and I want to get all the actors that have acted in that movie, and it will return the result back to you. Now I will just go to the same demo that we were showing before, but I will go into a little bit more detail. So the scenario for this demo, this application is, and it is available on GitHub. If you want to install it yourself, you can just go to GitHub, clone it, and you will be able to run it on your machine or laptop. So we have our legacy database. Now we want to modernize that application, and we have what we can do is that we can use a chain data capture tool to get the data from MySQL, and as the data changes also, we can get those changes and write them to Redis streams. Once we have written those to Redis streams, then we can transform it to multiple different kind of transformations and serve that data efficiently using Redis. So first of all, again, I will just go here, and if we go to my database, we will see that if I just refresh this database, I have only one key. So let's first of all, using a chain data capture tool, let's start getting data from MySQL and start pushing it to Redis. Redis as a company, we also provide a chain data capture tool called Redis Connect that you can connect to MongoDB or Golden Gate, capture the data and push it into Redis and do some transformations also on the way. Okay, so let's go here. And now I will just start the service. And what this is going to do is it's going to create streams and it is going to get the data for you. Now, if I go back to Redis Insight here, if we go to the stream section, we should see 3 streams and we should see many entries that have been added. They all are timestamped and we have our relevant information there. If we go to the consumer groups, there are no consumer groups at this time because no one has subscribed to those events to process them. And if I want to update the data, if I go here and if I just update, again, this movie, if I just turn it to 2016, I'll just submit it. And here in Redis streams, you will see that, okay, there is an update entry available for that, what I just did. Okay. Extremely simple to do it in code. So for the publishing, our CDC, it is getting the data. We are doing some transformations on that data, and we are putting it into a map. We already have our JSON connection to Redis configured. We get that data. We find out which stream do we want to publish to, and we just use the xadd command to publish it to the stream. Now, if we want to consume that data, I will start the service to consume the data. And I will go to the services and I will start consuming this service. Now we are consuming, and if we look at the data now, what we will see is that in the browser, there are, so if I just do it on star, movie and refresh. So we are adding a lot of movie data here, and still it is a key value stored there. But what we have also done is that we have created an index, and now we are also indexing the data. So we can do quite complex searches and build sophisticated user interfaces. Now, if I go back to the application and go to the searches here, and now this search that is backed by RediSearch. I think something is taking a lot of CPU on my machine.
Yeah, we have some lag on the screen sharing, Kamran. Yeah, it's coming.
Yeah, so yeah, I think it might be Zoom or Docker. Yeah, okay. Okay, so now you can do quite sophisticated searches there. So if I want to search for a movie called Forrest Gump, that will be the command, and I can do a search and it will provide me with that data. So now we have, rather than Redis just being a key value store, we can do very, very sophisticated searches there. And also you can go quite complex, like this, the genre, the count, this sidebar. Again, that is built using a Redis search query. So if I want to do that kind of a query, so if I just go to movies, the type is aggregation, and if I just go there and say that, okay, group by, and here I'm just saying that, okay, group them by the genre and just give me the count for each genre and sort it by genre in ascending order. If I run this, you can see that command there. And if I just want to do a simple search, you can also do quite a simple search there. So if I want to do a search again, like we showed in the user interface, you can do very sophisticated searches inside Redis. And if we go to the streams there, you will see that now we have consumer groups there. And I will go very, very quickly go through the code that, okay, for consumption, you just, there is a method, you just say that, okay, I'm creating a group, I'm part of this group, I'm this consumer, and start giving me the messages. You get the messages, you process the messages, and then you acknowledge the message so that it's not on the pending entry list, and it can be removed from that consumer's pending entry list there. Okay, and here you can see that, okay, there are consumers. Now, if I want to turn that data into graph, if I have connected data, again, I have a service here, and I can start the graph service now. Now, again, it's taking the same streams, reading the data, creating a graph, and updating the data inside Redis. Now, if I again go to Redis gears, sorry, Redis graph here, and again, I can run quite sophisticated queries, but I'll just run the simplest one that is going to do the match and give me all the data in a connected format. And you can see that that's the data I have. If I zoom into this, that's the movie and all the different connections between actors and different movies. And the in UK, the largest terminal provider, they use Redis Graph to map terminals and their locations and the organizations. They build that relationship using Redis Graph to provide real-time reporting on that. Okay. Now I will switch Redis gears. I will go very quickly. We are short on time. It's a dynamic framework. You can also write kind of stored procedures using Python, and Java is coming along inside Redis, that as something happens inside Redis, you can process the data, and a recipe is available. You write the data for data ingestion, you write the data to Redis, it goes to a stream, returns to the client, and then in the background, it can be written to the DB asynchronously because Redis is highly available there. And then we have Redis TimeSeries module. It provides you with a time series module for Redis. And the Redis Bloom, it provides you with 4 probabilistic data structures, a Bloom filter, a Cuckoo filter, top K, and minisketch for analyzing large, very, very large amounts of data using less memory. And the common theme about all those modules is they all work at Redis speed. They aim to provide sub-millisecond latency and a high throughput there. Now, I've gone through some of the capabilities for Redis. Now, if you want to move it into production, we've developed Redis open source. We also provide Redis Enterprise. Redis Enterprise, it is fully compatible with Redis open source, and it also comes with certified Redis modules, and it provides you with linear scalability. You can add nodes on the fly and distribute your data without any downtime. It provides you with high availability with replication across multiple availability zones and automatic failover for the clients. It also provides you with durability. So with Redis Enterprise, you can use Redis as a primary database. And there are multiple durability options available, backup and restore, as you would expect from a primary database. They are built in. It also provides active geo-distributed databases that you can deploy across multiple regions. Values are updated concurrently in each of the regions, and then it automatically does the conflict resolution for you and provides you with an eventually consistent data. And the reads and writes, they are at local latency. It's consensus free. Redis Enterprise also provides you with Redis on Flash, so it can use a fast NVMe SSD disks as an extension of RAM to keep the hot data in RAM and the cold data on disk, and it can give you about 80% of savings. It's multi-tenant also. You can provide Redis as a service to your organization or many of your or application teams there. And last but not least, secure end-to-end encryption, end-to-end node encryption on the data path, on the control path, integrates with LDAP, integrates with Active Directory, and you can provide ACLs or access control lists at a key level, which application can read which data. And it's available as a managed service, and it's also available as a software that you can deploy on a prem or on a Kubernetes. So I think just right on time. We will share this presentation. There are some additional resources also. Redis Insights, if you're playing, it gives you, rather than using the command line, it gives you nicer views. Redis Developer, there are lots of demos, lots of learning articles, and you can also register at redis.com for a free account if you just want to play with the Redis. And again, don't forget to register for the prize. We will be deciding about that. So if you just scan the QR code and enter your details, whoever wins, we will let you know. So Alex, do we have time for questions?
I see some folks, need to go maybe back to back with continuing the day, but definitely we can stay some more, like 10, 15 minutes. Happy to take questions. We had quite a lot in the chat, so I wanted to, thank everyone for the active engagement we had in the chat. There was lots of interesting questions about, clustering in scalability, especially for streams. And a few more, but yeah, some of you might just unmute and just open up for questions. Maybe I will reformulate one of the questions, Kamran, that was, I think, one of the most important one. It was really all about, how Redis streams is scalable, right? Can you scale the consumer group? And have multiple consumer, consuming concurrently from multiple thread or multiple machine? That was kind of question number one.
Yes, you can. The multi-threaded libraries, they support that, and Redis also supports that. So consumer group, it can have multiple consumers, and the consumers, they can consume from multiple threads, multiple machines, or multiple processes.
Right, and someone else, I think, was asking if the stream itself, which obviously is a stateful data structure, because you can keep the data for a little while up until the consumer comes in and consume or trim the stream, right? The stream itself is also scalable if you have a Redis cluster, with multiple nodes. You can scale multiple streams as well, right? Maybe
you can add multiple streams, but there is a pattern available for that. Generally, a key, it lives in one server, but there is a pattern available that where you can have streams on each of the different Redis processes.
Right. Yeah. I think generally speaking, any data structure for which you have a key, that key is on a single server. This is why when we store a hash, we have this key space, user colon and the ID of the user. So if we have another user and we operate in a cluster, that key, would end up maybe in another node, right? There's a distribution algorithm for the data set. So if your stream is on a single key, you only have one stream, which is a very extreme use case. Then you need to think about your design if you want to split that stream in multiple units, right?
Correct.
Yeah. Okay.
And there is a pattern available in Introduction to Streams. It goes through that also. Right.
Okay. Yeah. Got some questions about the protocols, right? So someone was asking, what's the protocol between client and Redis, as I understand. So yeah, it's a fully open protocol, right? So it's the Redis protocol. I mean, there's a version of the protocol, like protocol version 3.
Version 3 is the latest one. Yes.
Right, exactly. And it's TCP based, right? So it's designed for high performance, but also for reliability. Redis supports also, at least Redis Enterprise, supports some advanced capabilities like pipelining. So you can pipeline multiple operations into one kind of network round trip and optimize many things. but essentially it's a low-level TCP protocol. It's nothing to do with HTTP or things like that. This being said, there's a very famous use case with WebSocket. If you're using Redis PubSub, it's a fantastic backbone for any WebSocket architecture. So essentially your let's say Java application could be providing the kind of the WebSocket front-end part, and you can use Redis PubSub attached to the application to provide the distributions to many WebSockets, right? It's a very famous use case here. Some question in the chat by Joseph asking about higher level protocols like IMQP, JMS, Stomp, or others. If you want to look at this one, Kamran.
I don't believe these are very, very old protocols, JMS and part of the Java world, but no. Similar functionality, but in a much simpler and scalable way. Yeah, that Redis provides.
Yeah, we actually we actually have seen many times Redis being used as an event-driven architecture, and people essentially modernize the application as they adopt Redis, and they get rid of this JMS or IMQP or Stomp, and just use this Redis client library, 10 years of maturity into this client library, and also can do more, right? So that client library can be used for messaging and event-driven architecture, but then you can use the exact same library for cache or for storing data into JSON and search, etc. The same goes, I think, for JCache. This is already like JDis, Lettuce, and there are a few more Java client-based library. JCache was, historically it was a JSR, from the Java specification, group, but really, same thing, right? In few lines, right? Refactoring a little bit the application, you get essentially more capabilities by using Redis and client libraries like JDis, and most of the time the API looks really similar, right? Get and set into a hash map. Of course, if you have queues and locks, and list data structures and things like that, you need to be looking into the specifics. But usually, if you own the code of the application, if you're still working on it to improve it, you can definitely refactor it and use this, Redis client libraries to really get the full power of Redis. I think Andy was asking about this. Yeah.
Hi, Masoud here. Kamran, Alex, thank you very much for your presentation. Very informative introduction to Redis. Just like a quick question around Redis stream and using it as a message bus specifically for microservices. So with that feature, you kind of get into the realm of things, other products such as Kafka. So based on what you said, correct me if I'm wrong, Redis only supports at most once message delivery. Is there a plan to actually have guaranteed once as well?
So Redis PubSub, that is at most once. With streams, that it is at least once delivery. Right. Okay. So for the streams, is there a streams that do support at least once delivery? You send a message, you consume the message, and then you have to send an acknowledgement. If you don't, the message is on the pending list for that consumer, and you can ask. There is an API available where you can get the message again and see that which messages are unacknowledged out. So it supports at least once delivery.
But there's no guaranteed once delivery. Is that correct?
You mean once and only once?
Yes.
Once and only once, I believe for that, you do need a client application also to work with you. The server cannot support it just on its own.
All right, understood. Thanks.
Any more questions?
That's exactly what I was about to ask.
So I think we're going to, distribute the deck as part of the follow-up, right? In the deck, we will provide the link to the GitHub repo. It's really 2 lines, if you wanted to give it a try, if you have, Docker or, Docker on your machine. the whole application architecture we've seen will start kind of run out of the box without any complexity. You might need to have Java and Maven just for building the components in there, but it all runs on your local machine. Just git clone and give it a try.
Have we got any other burning questions just before I close? Okay, thank you so much, Kamran and Alex, for sharing that with us. That was absolutely fascinating from my perspective, and from the comments we've had in the chat, it was really interesting and really valuable for a lot of people who came today. So thank you so much for your time and presenting that to us. If you guys can obviously send me a link so that I can then send it out to the attendees today so that they've got that little bit of information like you've put in the chat already, that would be amazing if you're okay to do that. But from this point of time, I'd like to say thank you all for coming this afternoon. I hope you have a great afternoon, and we'll see you again at the next event. Thanks very much for coming. Have a good afternoon.
Thank you, Abby, for giving us the opportunity. Thanks.
Oh, no worries at all. Thank you.
Thank you.
Take care. Bye.
Bye-bye.